Welcome to part 2 of our exploration into OpenGL. A very chaotic exploration into OpenGL, where you are taught by someone who also doesn't know what they're doing. So, enjoy that. Don't know why you're watching this. So last time we did setting up an OpenGL window. That was fairly simple. And now we're going to get a little bit more complex and we're going to draw our first polygon. So that's going to be a bit mental. So, first things first. We still have our project from last time. Our project that doesn't do anything but it quits when we press escape. Boom. Fucking brilliant. So that's what it does so far. So here we have all our setup. It sets up a shit ton of things. Half of it we don't know what it does yet, we just accept that it sets it up. I'm mostly interested in the actual doing stuff bit at the moment. I didn't find out if that was necessary. Let's have a look. I don't think it is, you know. Nah. Okay. So while the display is not requested to be closed, we want to do all this stuff. Update the screen every 60 seconds. While we have keyboard events to look at, if the key that was pressed is the escape key, then we should break, and then if we should break, then we break. I didn't know how to break out the whole while loop from inside another while loop, so that's how I'm attempting that. We clear the background every time before we start drawing, so really we should probably draw here, because this is before the screen gets updated here. And after the screen gets cleared, so I want to draw after it gets cleared. So, that's where we are at this current moment in time. So our next step. In this tutorial I will teach you how to create both triangles and quads. We will create a triangle using GL triangles and a square using GL quads. Using the code from the first tutorial, we'll be adding to the draw GL scene procedure, which we don't have, we just kept it in the same function, whatever. I will rewrite the entire procedure below. If you plan to modify the last lesson, you can replace the draw GL procedure with the code below, or just add the lines of the code below that do not exist. Yeah, we've done that. Got that. When you do a GL load identity, okay, so what does this thing do? What you're doing is moving back to the center of the screen with the axis. Can't speak. Running left to right. The y-axis moving up and down, and the z-axis moving into and out of the screen. Okay. So does it do that every time we call that, or does it do it differently depending on what we're doing? I don't know. Center of an OpenGL screen is 0, 0 on the x and y axis. To the left of the center would be a negative number, to the right would be a positive number. Okay, that's fine. So, just in case you're physically challenged. There we go, there's our axis. Boom. There's our y-axis. I could have just found a picture on the internet, you know. X, Y, Z axis. Boom. Boom, boom, boom. I want you in my room. That's actually looking at it from a different angle. Oh, fuck this. Who gives a shit? Whatever. Where am I? Oh, balls. Okay. So, the axis to the plus x is to the right, negative x is to the left, plus y is up above, negative y is below. Deeper into the screen is negative Z, and towards your face is positive Z. GL translate XYZ moves along the XY and Z axes. Why do I keep saying that wrong? Axis, in that order. Moves along. GL translate moves along the XY and Z axis. What does that mean? The line of code below moves left on the x-axis 1.5 units. This does not move on the y-axis at all. And it moves on the screen 6 units. Into the screen 6 units. When you translate, you're not moving a set amount from the center of the screen, you're moving a set amount from wherever you currently were on the screen. Okay, so it's like a pointer to where we're currently pointing at on the screen. So you can imagine it as the cursor, basically. So GL translate from that, if my cursor was there, go minus 1.5 to the left, negative 6, which, if I recall, is deeper into the screen, which I can't actually simulate with my mouse, which is only moving on a 2D plane. But yeah. So now that we have moved to the left half of the screen and we've set the view deep enough into the screen, minus 6, that we can see our entire scene, we will create the triangle. Okay. Deep enough into the screen that we can see our entire scene. What does that mean? Oh well. GL begin, GL triangles means that we want to start drawing a triangle, and GL end tells OpenGL we are done creating the triangle. Typically, if you want 3 points, use GL triangles. Yeah. Drawing triangles is fairly fast on most modern video cards. Just put that word modern in there, I don't know why. If you want 4 points, use GL quads to make life easier. From what I've heard, most video cards render objects as triangles anyways. Finally, if you want more than 4 points, use GL polygon. Okie doke. In our simple program, we draw just one triangle. If we wanted to draw a second triangle, we could include another 3 lines of code. 3 points. Right after the first 3. All 6 lines of code would be between the GL begin, GL triangles, and GL end. There's no point in putting a GL begin and a GL end around every group of 3 points. Okay, so it's just setting a sort of mode that doesn't really it doesn't come out of the mode until you do GL end. So if you do more GL begins, it's just going to set it back into the mode that it's already in. Does that make sense? This applies to quads as well, yep. If you know you're drawing all quads, you can include the second group of 4 lines of code right after the first 4 lines. That is fine. A polygon, on the other hand, can be made up of any amount of points, so it doesn't matter how many lines you have between GL begin and GL end. Actually though, that would be different though, wouldn't it? Because it would draw it as the same shape, whereas if you included 6 lines between 2 GL begin and GL end triangles, you would end up with 2 triangles, whereas with a polygon you'd end up with the one shape, so it's slightly different. At least that's what I would imagine. The first line after GL begin sets the first point of our polygon. The first number of GL vertex is for the x-axis, the second number is for the y-axis, and the third number is for the z-axis. So in the first line we don't move on the x-axis, we move up 1 unit on the y-axis, and we don't move down on the z-axis yet. So this is the first one. We don't move on the x, we move on the y, plus 1, and we don't move on the z. So we're going up from, I guess, our pointer, a little mouse that we set somewhere on the screen. It'd be good if he explained it like this, wouldn't it? Yeah. So, that's fine. We move up 1 unit on the y-axis, and we don't move on the z-axis. Yeah. So that's the top point. A second GL vertex moves left 1 unit on the y-axis and down 1 unit on the z-axis, on the y-axis. So this is the bottom left point. Yeah. So that's going relative from this, or is it going relative from the translate that we set earlier? Who knows? Who fucking knows? Second GL vertex moves left 1 unit and down 1 unit. This gives us the bottom left point of the triangle. The third GL vertex moves right 1 unit and down 1 unit. Okay, so we're going relative to this. We're not going relative to the previous points. And I know that because if we were to go relative to this, we would end up like at the bottom of a diamond shape. And we end up at the bottom right. So we're going, yeah, that makes sense. So we end drawing the triangle, yeah, okie doke. Now we create a square. Oh wait, no. Now that we have the triangle displayed on the left half of the screen, we need to move to the right half of the screen to display the square. In order to do this, we use GL translate again. This time we must move to the right. So x must be a positive value. Because we've already moved left 1.5 units, to get to the centre we have to move right 1.5 units after we reach the centre. So the GL translate is actually going relative to the previous GL translate. And apparently we start in the centre. Start in the centre. Centre of an OpenGL screen is. Okay. So we started in the centre, we moved to the left, and into the screen, back a little bit. Z, back, yeah, okay. And now we're moving to the right, and we're staying at the same depth level, and we're staying at the same Y level. So we're still at 0, right in the centre of the screen. Vertically, yes. Now we create the square. So this is in the same fashion as the GL triangles. So let's try this actually, just now, before we... Okay. So this will be an experiment. GL begin. Triangle. Triangle? Nope, already forgotten. Oh, triangle. Triangle. GL triangles. And we want to do... Forgotten? Forgotten already. GL vertex 3F. Now, the vertex is obviously a point, that's what a vertex is. The 3F means that we're going to be giving it 3 float coordinates. So there's different methods for different arguments. We could actually give it a point in 2D space as an integer if we wanted to. We could try that actually. Should we try that? Let's try that. So let's try minus 20, 29 even. Okay. Positive 20. It's going to be to the top left. It's going to be a weird triangle. No, so that's the top left. Top left of a triangle. Okay. So I guess now we want to be at the bottom. So this will be 0. Then we want to do the right hand side, which will be plus 29 and also 0. So it's going to be a right angled triangle, I think. We want to end that now. Is this going to work? It'd be funny if it does. Nah, of course it doesn't. Of course it doesn't. We don't know what we're doing. Don't know what the fuck we're doing. Do we need to do that first? GL translate, maybe? GL clear, GL load identity. We did that up here. Maybe... In fact, this probably won't make any difference whatsoever. Maybe they do need to be 3D points. Maybe they do. Let's try that, shall we? 3F. Actually, let's keep them as integers, because I reckon that'll still work. If that's even a function. Let's keep the Z as 0. We don't really care about the Z, do we? It's the depth. We've only got one object, the depth doesn't matter. And that doesn't work either. What if I set the GL clear colour to white? Well, nothing. 3F. Yeah. Nah. Maybe we need to do GL translate. 0, 0, 0. No, let's put -6 because the guy put -6 for some reason. Ooh. What's that then? What's this? What have I done? What have I done? In the water. Okay. Let's set it to what he's done then. 1.5f minus 6f. Let's keep these at 0. So just do 1, minus 1, minus 1 in the middle. So 1, minus 1, minus 1. And 0, minus 1, minus 1. 0, minus 1, 1 even. 0, 0, 0, GL end. So what's he done here? Return true. That's all he's done. So why isn't this working? GL load identity, reset the view, clear the translate, begin, end, translate, begin, end. Ah, okay, so now that's working. Right. So these are massive points. So that's only one. What the hell? How big is this scale? What's going on? Right. So that's the y-axis, isn't it? So that's the second point. It's getting deeper and deeper. Right, okay. So how deep does the screen actually go? And does it vary depending on... it doesn't. Okay. So I'm guessing that the actual center of the screen is only relevant when it's full screen because we haven't adapted the size of our canvas to fit the window. So it's not scaling it, it's just working as if it was using the whole screen. Ooh. Okay. So, that's interesting. So, maybe we missed something here. Let's have a look at the source code for this one, which I've already got. I just duplicated it. Okay. So I think we missed some of this. Wait, no, we didn't. We did this stuff. We did this. Did the projection, load identity. I'm just going to open this. Excellent. Okay. Look at that nice plain text. So render GL. Clear, yep, okay. Load identity. Translate, yep. So that's the drawing part. Shade model, we did that. We cleared the color, we cleared the depth, I think. We did the depth test with the depth function. We did the, yeah, we did that. Yeah, okay. Okay. So I guess at this stage, that's all we should really be doing. I'm just going to go ahead and turn VSync on. It's probably already on, to be honest. I think it is, but I do like a good bit of VSync. Always like a good bit of VSync. So I guess that's it for this tutorial. I think we did everything. So let's have another look. So all he's doing here is just creating the window and killing it. Yeah. Okay, this is into dusting. Units. So we're moving in units. line of code that moves left does not move on the y-axis. Yep, units. What are units? The answer is no. I mentioned inches and millimeters. Do these really have anything to do with OpenGL? The answer is no. The projection and other transformations are inherently unitless. If you want to think of the near and far clipping planes as located at 1 and 20 meters, it's up to you. The only rule is that you have to use consistent unit. Yeah, okay, that's fine. That's it for this tutorial. Should we do something interesting with this? What could we do with it? We could rotate maybe the triangle somehow. Although I don't know how to do that. I don't know how to rotate shit. We could move it up and down. Move it up and down, I guess. Let's do that. Okay. Triangle y equals 0. And then at the end of everything we go, if, what is it doing over there? If triangle y is, greater than 1, triangle y, no wait, boolean, no, int direction equals 1, so we're going to be moving upwards to start with. If triangle y is greater than 1, direction equals minus direction, so we'll flip the direction. Else, if triangle y is less than minus 1, we'll direction flip it again. In fact, why don't we just do this? Or it's nice and simple. And then we will simply triangle y plus, oh wait, we want to make that a float really. Plus, and we'll move it by 0.05 each time, times the direction. So regardless of whether it's moving up or down. And then we'll set the y so we want to do y plus that, because that's the y. So we want to move it all relative to the y that it's at. I've got no idea if this is going to work, by the way. I'm fucking shit at maths. Whee! It works! Guys, it works! I've got a moving triangle! Oh, brilliant. I could even do that with the X as well. Do something funny though. Do some weird shit. I don't know what's going to happen now. Oh my god. Okay, let's make that times that. It's going to be crazy. Oh wow. Okay. So that's it for this mind-blowing tutorial right here. If you didn't understand anything, I'm sorry. You can ask a question if you want. I'm not going to guarantee that I'll know the answer. I'm just doing this, so just doing it for attention. Just doing it for attention. I like attention. I'm a bit of an attention whore. So there you go. See you guys. Bye.